Okay, so we'll try this out today. It's been quite a while, a bit busy, but let's see. We were rewriting the main original, so we've got here on the right side the main original. I hope you guys can see this because I'm using a high resolution display. It's readable somehow. If not, the project is available anyway, so you should be able to basically go and check out the code as well and kind of Replit has this cool stuff where I think, but I'm not sure if you can fork these and then actually go through the history of the files. Probably not, but anyway. So we were rewriting this stuff because why were we rewriting this stuff? I think, of course, the history of Ghostwriter is gone. It would be good if this would stay somehow, but anyway. So I was just going through the vocabulary stuff. That's true. That's true actually. So we needed the vocabulary stuff, and then we're tokenizing. We said we would still use the old part of the tokenization with the palette tokens, and then cast the nested list to an NumPy array. So to kind of basically have these inputs, and then we were working on the splitting the input sequence into examples and targets. So now I think I'm going to leave this for the next session maybe, or for later on. That's not so important, but let's just focus on these. So let's ask Ghostwriter again. So still the question is like, so how should I, so in order to build an LLM like ChatGPT or like GPT, the goal of next Carter prediction. How should I structure my data, my training data? So is it short sentences and off? How should I split between sort of input and output, maybe? Input and output. Properly short sentences can work, but it's generally more effective to use longer sequences to capture more context. So one common approach is to split your input text into chunks of fixed length. For example, you can define a window size that determines how many characters to consider as input for each prediction. You can then use a sliding window approach to generate training examples by moving the window. I think I'll go with these. So preprocess input text, remove unnecessary characters, punctuation, blah, blah. Define a window size. Generate training examples. Use sliding window approach to generate training examples. So slide the window over your text by one character at a time. And for each window position, extract the preceding characters as the input sequence, and the next character as the target output. Okay, so it's that simple. Encode your input, convert each character to numerical representation. So that happens before the input. Prepare the input target data. So split your input data into input sequences and corresponding target outputs. If your input sequence is hello world, the target output is O, your input should be hello world, and the target output should be O. What? Optionally create batches. Remember the size of your data set and available resources, you may want to create batches for training examples to make training more efficient. Grouping multiple input sequences and target outputs together. That's what I thought we were doing here. So I think let's just work on that. This is what we're like. So can you give me some base data example and the code to make the transformations 1, 2, and 3 from your list, right? 1, 2, and 3 from your list. So here's an example of say transformation mentioned. So input text, loading ipsum, blah blah blah. Remove unnecessary characters and punctuation. Define window size by sliding window approach. Input sequences, target sequences. It's target text. So what is the role of target text in here? So because I believe so in the code snippet you share both. Apologies for the confusion. The code snippet provides the target output for each input sequence. In the context of training element for next prediction, the target refers to the character that follows the input sequence. Yeah, that's odd. I don't think this is correct. For example, if the input sequence is lorem ipsu and corresponding target output is m, then the target text would store the next character that should be predicted given the input sequence. So can you rewrite the code example above by just using longer input text and use this single variable to then generate the input output pairs. And also group it in batches of 4 pairs. Interesting. This actually is used. Is using as a baseline this instead of the snippet that they shared. But okay, I can work with these. So we can work with these. Still splits in sentences. And then during the input output pairs. Let's see how that works. Batch size. Let's see how that works, okay? So we'll, instead of these sentences, we'll just use this piece of code. So we'll use this. Then we get the sentences, then we generate the input pairs, and then we do the batch. And then so let me just basically print batch pairs. Batch pairs. Can I just comment that out? Here's to that. I'm not so sure if it works well. It's too much. I believe Common multiple lines in Python. Can you do that? Because then I just go here and do that. Okay, so, and this is now main Python. So let's just run it. What? So, lorem ipsum. So that's a pair. That's not what maxlen is for. Need something else window size. So for I in sentence, so for instance in enumerate sentences, then the input sequence so let's just don't need that. So given this text, so let's give it a bit more. So given a text, need a code to generate batched input and output pairs. A window size specified by a variable and with the goal to have structured data for an LLM next character prediction model. So let's try that out. So window size, so we're gonna just do window size 3, and then we have the text, and then don't know why they're using, I mean, I guess the sentences splitting makes sense, maybe, because it's kind of like a natural way of splitting things, I guess. So, branch pairs. Let's see what we get now. So why? Huh? There's something wrong in here. Sentences, window size. It's not sequence. The window size. Shouldn't the window size be used just for the just for sizing? the input plus output code you gave me to use it also with sort of with the number of sentences. Come on, that's not what I mean. That's not, no, why? That makes no sense. If I just get rid of these. Yeah, okay, that makes more sense. Then it's like, it still seems odd. What I would expect is that it's basically taking a window and sliding it like, so you take this window and you slide it by like character, almost character by character, word by word. So shouldn't, that's kind of correct, isn't it? So it's basically the input sequence is the sentence. So do we need to split? Okay, so do we need to split the text in sentences at all? Let's try this out. Sentences. That will be my. Oh, come on. So, but that's not really what we want. The question is, I don't know if what I want is what's the correct thing to have. You know what I mean? So in here, the preprocessing remove any is a kind of define a window size. By one character exactly. Follow these. You gave me these instructions. So you gave me these instructions. Please give me code that implements them. So window size and then training examples. That's wrong. That's not sliding the fucking window by one character at a time. Is it? Why? Oh no, wait a second, it should. No, that's correct, because so you do these, yeah, because you have the window, right? So you if the window size is 100 and the text length is 100, that's my point, then So if the window size is 3, yeah, no, that makes sense. Yes, yes, no, that actually makes sense. Let's see. So, but we're not going to do the cleaning of the text because I actually want to predict the things as well. So, let's see. Okay, yes, yes, that's what we want. That makes sense. Let's put a window size of what, 10. I'm not so sure if the spaces make sense or not. What if we say 50 characters? Right? Okay, so those are basically the pairs. Cool. Perfect. That looks actually good. So, can you now give me code to put these pairs into batches of batch size? So, essentially, exactly. What we've got, so let's say batch pairs 0. Why do I say 0 and I put 1? Okay, so that's the first batch. Oh, okay, that's better. So we have these pairs now. Now, now that we have the batch pairs, um, so we now should tokenize these. I guess that's the point, right? So we have these batch pairs. We should tokenize these. Really? Yeah, I guess we should tokenize these. But the thing is, the way that I had it here is the tokenization, right? The tokenization here is basically just turning the sentences into these tokens. Okay. Okay. And each word, in this case, each word was represented by a series of kind of like the basically the character by character, like the ASCII representation. So what's the best now? So what's the best strategy to tokenize? Should we tokenize Should we just do indices of the vocabulary? Um, is it taking that long? Okay, so can you adapt the, because what this was using is was going sentence by sentence. It was taking the words, and then the yeah that this max len here makes just no sense. This is window size really. It's window size. So I think I need to scrap that. I think I need to scrap that basically. Give me code that tokenizes the patched pairs, so I can use them later on for LLM training. Next character prediction. Let's see, and we'll leave it here. So what the tokens? What? What is that giving me? Say cents. To given this code, to now tokenize and patch pairs. Using basically kind of word, I guess word by word. Need the code to do it word by word and using sort of D model length arrays, right? With thing, if needed, 10. Yeah, exactly. Words longer than 10 letters, I don't know what's going to happen, but sure that does that to work. So let's just do a quick test. What the hell? I don't think that's doing the job. What? Tokens. So what happens if I do tokens 0? So I think I'll leave it here, guys. But we're almost there. Token 0. So what is it doing? That's just a big array of tokens. That's not the point. You need to keep the structure. So you keep the input output pair structure. What? No. Since when? No. I mean using. So what I mean is using the same structure. All you need is these. I need a tokens variable that has the same structure as the batched pairs, but instead of words, we got list of tokens. I think I have to give it a bit more concrete structure because I don't think sure that's going to do the job, but let's see. That's definitely not doing. Oh yeah, wait. Yes, so you've got all these, and then you've got 32. Okay, we've got all these, and then you've got yeah. Okay, that's all good. So you've got the pair structure at least. Cool. Tokens 0. Can I do like that and see what happens? Do I get, yeah, I get the first pair, so. Okay, so that's all the characters, including the spaces. I'm not so sure if that's the right thing to do, though. Thought we wanted to group, this makes sense to group the words. So I think that will be the next to do, so for the next session, does it make sense to group by words? I guess that's the point, yes, I guess that is the thing, right? That's what we want to do, group by words. The problem, what I'm having here is like, if you group by words and then you're predicting next character, this kind of character is just not a word in the vocabulary. You know what I mean? I don't know how you work around that. I don't know how you work around that. So that's going to be the next question. If we tokenize at word level and have a vocab at word level, how do we encode broken words in the output? Or should we then shift to word prediction and not character prediction? Okay, so let me ask this to Ghostwriter, and let's just go. Okay, so I need to hop onto this thing. Okay, you can exclude them. No, but that makes no sense. No, that just makes no sense. There's something that I'm just missing here. Think a little bit about more. Anyway, see you next time.